In this video, I go through 12 different examples of simplifying complex fraction. We start with the most basic and then move ourselves on to when we have one fraction, two fractions, three fractions, as well as four fractions. I hand selected these problems to help you understand how to simplify complex fractions. So by going through this whole video, you are going to have a strong understanding and foundation to be able to simplify any complex fraction you have to do on your own. I hope you enjoy.
Welcome. So what we're going to do is look at this is simplifying our complex fractions. So we're going to go off all the knowledge that we've had about simplifying rational expressions and then also dividing rational expression in this case. Now, what we see here is we have a rational expression being divided by an integer. All right, I'll actually use a different thing. So what we're going to do is when dividing this, what we want to do is kind of rewrite this as a fraction. So I'm going to rewrite the 3 as 3 over 1. Okay, so now you can see what it is a rational expression divided by another rational expression. This one just has integers. So therefore, what we can do is we can rewrite this problem as being multiplied by the reciprocal. So what we're trying to do, the reason why, again, why we multiply by the reciprocal is if I want to get this fraction off the bottom and I only want to deal with one fraction, I'm going to have to multiply by the reciprocal. Now remember, to keep equivalent fractions, whenever I multiply in the denominator, I have to multiply in the numerator. So now what I have is a problem of 2 divided by x plus y times 1/3. Well, when we multiply fractions, we just multiply directly across. Therefore, I have 2 over 3 times x plus y. And there you go, ladies and gentlemen. That's how you simplify your complex fraction. Thanks. So in this example, as I mentioned, guys, whenever you have a fraction divided by another fraction, the main important thing is to multiply by the reciprocal. Because what's nice about that, if you were to kind of put these in parentheses here, you guys can see that each of these are now separated by multiplication, right? Do you guys see each of these quantities are separated by multiplication? Therefore, we can apply that division property I just spent 5 minutes explaining. So now, multiplying a fraction by its reciprocal, doesn't matter how crazy the fractions look, is automatically going to equal 1. So now, however, now our denominator is equal to 1. But remember, to keep equivalent fractions, if you had the fraction 4 over 5, and you just multiply the denominator by 2, you now have 4 over 10. Those are not equal to each other. But if you have 4 over 5, and you multiply by 2 over 2, you get 8 over 10. Do you guys agree with me that 4 over 5 is equivalent to 8 over 10? Yes. So whatever you multiply in your denominator to produce equivalent fractions, you have to multiply in your numerator. So basically, for your complex fractions, you're just going to multiply by the denominator's reciprocal in the numerator and the denominator. Now, over here, the problem with this is these look very similar to each other, right? Yes. They're almost the same, but they're not. So, but one thing I could do is this is negative, that's negative. That's positive, that's negative. I could always factor out a negative, which would make that a negative. Actually, let's do this in black. If I factored out a negative here, that would turn that to negative and that to positive. Would you guys now agree that those two are the same? What do you mean, sure? Negative x, negative x. Positive y, positive y. They're just flip-flopped around. Yes? I'm just factoring out. I'm not changing the value of anything. For instance, if I had the example x plus 3, right? And let's say I factor out a negative. When I factor out a negative, that makes that negative, and that makes that negative. Do you agree with me that negative times negative x and negative times negative 3 is the same thing as positive x plus 3? It's the same thing. So factoring is not changing the value. It's just rewriting it in a different format. Does that make sense? So since I factor out the negative, notice, negative times negative x is that's still equal to positive x. Negative times positive y is still equal to negative y. So I didn't change the value. By multiplying by the reciprocal, I changed the value, right? That's why I had to do that on top and bottom. But factoring, I didn't change the value. I just changed the form. So now I could apply the division property. Just remember, though, there is a -1 there, though, still. All right? Then we can use our rules of exponents. 6x squared divided by x cubed. X squareds will divide out. That will leave me with a 1 on the bottom. So my final answer is going to be a 6 over negative x. And we can just write the negative out in front. The first thing you guys want to do for this whole focus lesson is simplify by factoring. Up here, I notice I have a square term minus another square term, so I can simplify that using the difference of two squares. So I'm going to factor that into x minus 3 times x plus 3. Over here, I can factor out a 6. So when I factor out a 6, I'm left with a x minus 2. In the denominator here, I need to determine what two numbers multiply to give me 21 and then add to give me 10. So I can factor that into x plus 7 times x plus 3. And then over here, I need to figure out what two numbers multiply to give me negative 2, add to give me negative 1. So that would be x minus 2, x plus 1. OK. So now there's a couple different ways we can do this. All right? And I think the basic thing when dealing with a complex fraction is when you guys actually look like a fraction like this, basically what this is division over division. Right? Dividing, or basically you're taking a fraction divided by another fraction, right? So basically what I can do is just multiply by the reciprocal of my divisor. So basically I can rewrite this as x minus 3 times x plus 3 all over 6 times x minus 2, and then multiply it by the reciprocal. Because whenever you have a fraction in the denominator, if you multiply by that reciprocal, that's how you get rid of it. Those divide out. Those divide out. What did I not write? Oh, I didn't write it correctly. Those divide out, and those divide out, right? Using our division property, if you multiply a fraction by its reciprocal, the division property makes everything 1 in the denominator. Does everybody see that? But whatever you do in the denominator, you have to do in the numerator to make sure that they are equivalent fractions. So I'd have to multiply my numerator times x plus 1, x minus 2, over x plus 7 times x plus 3. And that's what that would look like over here. X plus 1 times x minus 2 divided by x plus 7 times x plus 3. Now I can use the division property. And remember, the division property works only across multiplication. Well, you guys can see that I am multiplying each of these quantities are separated by multiplication, right? So I can use the division property. I can use the division property across multiplication. Inside the parentheses, there's adding and subtracting, but that's fine. So here you can see that x minus 2 and x minus 2 by use of the division property goes to 1. And then I have an x plus 3 and an x plus 3. By division property goes to 1. Since I'll be nice to you guys, we will leave this in our factored form. However, if you have a test and it's asking you for it to be expanded, or the answers of a multiple choice test are expanded, please note that you'd have to expand that into x squared minus 2x minus 3 over 6x plus 42. Right? But I like this form. Why would I like this form? Does anybody have a random idea why I would like this form? It's going to be something we're going to talk about. Yeah?
If you're going to put it in other equations, it makes it easier to cancel.
Well, it would be easier to cancel it out. And I just like the simplified form. There's also something that starts with a D and rhymes with romaine. Domain. It's really easy to figure out what the domain would this one be, right? This one, the domain, we know that x cannot equal 7, right? So it'd be negative infinity to 7. What's also nice, but what's nice about this one is now we can also, or it's also easy to figure out what the asymptote is. X equals negative 7 is the vertical asymptote. It's also good, but this form is nice to look at the horizontal asymptote. Because remember on your test, the horizontal asymptote, you have to compare the degrees, right? Here, it's not so obvious what the degrees are. But when you expand it, you can see that the degree in the numerator is greater than the degree in the denominator. Therefore, no horizontal asymptotes exists. But basically, ladies and gentlemen, we've talked about simplifying. We've talked about dividing, multiplying, adding, and subtracting, right? We've also talked about solving. So if you guys look at this, this is what we call, we're doing division again. But we have a rational expression divided by another rational expression, okay? So this is a little bit different than everything else we've done. Yeah, we're dividing, but we're not dividing like expressions. Now we're dividing like two expressions, right, that need to be added. So the best way that I like to do this is, again, get rid of your fractions, okay? So the best way to get rid of the fractions, guys, is you can see there's 1, 2, 3 denominators, right? You guys can see here's the big division problem, right? In each of these, I have a denominator of 2x plus 1, 2x plus 1, and x. Again, kind of like solving, we want to get rid of fractions right now, okay? So what I'm going to do, to get rid of them, I'm going to determine the LCD. Does anybody want to give me the LCD for this? X times 2x plus 1. Does everybody agree with that? OK. Well, we don't have to distribute yet. So now, what you're going to do to eliminate the fractions to help you simplify this problem, you're going to multiply every term by the LCD. So you guys see how I have 3 terms here? Remember, terms are separated by addition or subtraction. There's only 1 term in this denominator. There's 2 terms up here. Now, we apply your division property. The x's divide out. The 2x plus 1's divide out. The 2x plus 1's divide out. So now, by simplifying this, I now have, in my numerator, 2x plus 1 plus x divided by x times 4x is 4x squared. You guys see that? See what I did? What happened? Anybody have any questions with this so far? We still can simplify it. But now, I can simplify up here, right? So I can say this becomes 3x plus 1 divided by 4x squared. OK? Now, one thing I want to go through, guys, is we could do this the way that the last method I told you, by adding these equations up and then dividing them, right? So it makes sense. You can add them up to the side, see what they get them to one rational expression, and then you can divide them. There's another thing. When you guys were learning equations, one thing we had is, let's say I had like 3/4 x plus 1/8 equals 11/12. Okay? If you had a problem like this, all right, one of the ways to solve an equation like this is what we call like fraction busting. Just get rid of all of the fractions, right? So what we would do is we'd multiply everything by our least common multiple, our least common denominator, to get rid of the fractions. So if you had an equation like this, right, guys, none of them have the common denominators. This would just be a mess trying to do all fraction operations, right? Yes? Would anybody want to do this? No. But what you could do, if I said, all right, the LCM of all my denominators equals 12. So if I multiply all of my denominators by, or every single term by 12, is my equation still equal? As long as I do whatever I do on the left side, I do on the right side, is that good? So since I multiplied both terms by 12 on the left side, I multiply on the right side, my equation's still true, right? OK, but now what happens? That goes to 1. OK? That goes to 3. And this would now, simplify down to 3/2. So I don't get totally rid of everything. However, is this a lot easier to go and work with than what the previous problem was? I didn't get rid of all the fractions, sorry. But I made it simplified, right? So that's the exact same thing. Notice, though, guys, as long as we do it to everything, we keep the equation equal. Well, that can be the same thing when you have a rational expression. As long as you multiply your numerator and your denominator by the same number, you keep what we call equivalent fractions. So what would be my number, or what would be my value that I'd want to multiply the numerator and the denominator by? Well, in an equation, when I had fractions, I multiplied by the LCM. So do you think I might want to multiply by the LCM for my fraction? Yeah. So let's go ahead and determine what is the LCM then of this expression. So here I have a denominator x minus y. Here I have a denominator x plus y. And here I have a denominator of x minus y. So what do you think the LCM would be for those two? What do you say, JD? There you go. So what I'm going to do then, ladies and gentlemen, is I am going to now multiply my numerator times x minus y, x plus y. And I'm going to multiply my denominator by x minus y times x plus y. Does everybody understand that these are going to be equivalent equations? Yes. Everybody agrees with that? No? Okay. Well, Dimitri.
I'd say no.
No, I'm just kidding. So if you had 3/4, right, and you multiplied by 2 over 2, you would get 6/8. Is 6/8 the same thing as 3/4?
Yeah.
Of course it is, right? Good job. OK. So now we have to apply. Here I have an expression. So I need to apply distributive property. Well, ladies and gentlemen, when I apply distributive property, the x minus y divides with the x minus y to give us 1. So therefore, I'm only going to be left with 2 times x plus y. When I multiply x minus y times x plus y times this, my x plus y and my x plus y divide to 1. So I'm just left with x minus y. When I multiply my common denominator, or my least common multiple, times this, my x minus y and my x minus y divide to 1. So I'm just left with x plus y. Any questions on that step? Yes, Ashley. You have that great look. OK. So now what I'm going to do is I can't break this up because I have this addition. So you can't just say, oh, those divide out, because you have addition separating them. So what I want to do is now simplify this to give me 2x plus 2y plus x minus y over x plus y. Then we'll move it this way. And we'll say 2x plus x is 3x. 2y minus y is going to be y all over x plus y. And no, ladies and gentlemen, those do not cancel out to leave you with a 3. Because you'd have to factor out a 3 for them to be able to divide out. So that would be your final answer. OK? Alex, did you have that written down? Do you? OK. So just like in solving, yes, ladies and gentlemen, these do not have common denominators. So yes, you could find the common denominator and then add them, right? However, what I think is the easiest thing to do is identify the common denominator and then multiply, like we did for solving, multiply every single term by that common denominator to eliminate your denominators. So the first thing we want to do is factor to find our leading coefficient, our common denominator. Here, I can factor out a 3. So that would give me, what? I didn't hear you. I'm sorry. Yep, 3 times x plus 5. Here, I can factor out a 4. So that's going to give me 4 times x plus 5. OK? It was 4x plus 20. So now what I want you guys to understand is my common denominator is not just x plus 5, but it's also the common denominator of 3 and 4, which is 12 times x plus 5. Basically, I mean, for those that works. Huh? I'm not done yet. Now, as I mentioned, I'm going to multiply every single term like I did for the equations. It's the exact same thing as the equations. You're going to multiply everything by your LCD. 12 times x plus 5. Why? Because all of the terms, x plus 5 divides into all of these. and 4 and 3 and 1 all divide into 12. Now, and that's what you want. You want your denominators to all be able to divide into your LCD. Now, what I notice is x minus 5 and x minus 5 divides to 1. 12 divided by 3 divides to 4. Over here, x minus 5 divided by x plus 5, that gives you 24 over here. And here, 12 divided by 4 divides to 3. X plus 5 divided by x plus 5 divides out. So now what I'm left with is 4 times 2, which is 8, over 12 times 2 is 24. And this just becomes plus 3. Well, now can I add 24 and 3? Yeah, sure. Of course you can. That's it. Now, I know if you're not getting excited to do this problem, something's wrong with you, because this one looks like a great problem to be able to work on. So we have a complex fraction. And remember, when simplifying complex fractions, we got to get rid of our fractions in our numerator and our denominator. Now, one thing we could do is we can multiply everything by our LCD of every single denominator, and then that will eliminate our fraction. That's possibly one way we could do. The other way we can do is when we have multiple fractions, either in our numerator or denominator, we can find the LCD, get them to have common denominators, and then combine them. And then we'll have a single fraction in the numerator and denominator, and we can multiply by the reciprocal to eliminate all of our extra fractions. So before we get to a point like that, though, we need to look at this and say, all right, always where can I simplify my problem as much as possibly I can? So I look at this and I say, all right, in this denominator, I have an expression I can simplify. And here I have a trinomial that I want to see if I can simplify. Now, the reason why I know I can simplify this is because I see that they both share a 3. So what I'll do is I'll just write this over here. So if I have 3x squared minus 3, I know I can factor out a 3, which will give me x squared minus 1. Now, x squared minus 1, we notice that's also a difference of 2 squares. So I can rewrite that again as x minus 1 times x plus 1. All right? So that's very understanding, our common factoring techniques and really realizing our difference of 2 squares. Now let's go and take a look at our trinomial. So I have x squared minus 3x minus 4. Remember, what we want to do is determine what two values multiply to give us negative 4, but then add to give us negative 3. And this can be multiplied by x minus 4 times x plus 1. All right? So now what I'm going to do is I'm just going to rewrite these two denominators in our factored form. Okay, and then over here I have x minus 4 times x plus 1. Okay, so now what we need to do is we need to find our common denominators of these two fractions. Well, we notice they both share an x plus 1. However, this one has an x minus 4, so we can say our LCD is going to be x minus 4 times x plus 1, just for our fractions in our denominator. So therefore, now I need to multiply. This already has my LCD. So over here, I need to multiply by x minus 4. Okay, and then I simplify this. And I'm just going to kind of work this way again. By simplifying this, I'll have my numerator is going to stay the same. All right, but then now in my denominator, I'll apply distributive property here. And then also notice this negative sign. I need to make sure I just apply distributive property there. So therefore, I'll have 5x minus 20 minus x minus 4 all over x minus 4 times x plus 1. All right, so now I see that I have some terms I can combine. So I'll do this one more time as 1 over 3 times x minus 1 times x plus 1 divided by, here I'm going to have 4x minus 24 over x minus 4 times x plus 1. OK, so the whole purpose of this is you can see that now what I did is I combined these two fractions into one simple fraction. Now I can multiply by multiply by the reciprocal of this fraction to the top and the bottom to eliminate my fractions in both the numerator and the denominator. Before I do that, though, I am going to want to simplify that numerator right there. So therefore, I have 1 over 3 times x minus 1 times x plus 1 divided by, simplified form would be 4 times x minus 6 divided by x minus 4 times x plus 1. So now I multiply by the reciprocal, which will be x minus 4 times x plus 1 all over 4 times x minus 6. And remember, we do that in the numerator, and we do that in the denominator. Okay? And by doing that, what we notice is, remember, whenever you take a fraction and multiply by its reciprocal, that multiplies out to 1. But then we look at and up here in our numerator, we know that this x plus 1, so notice everything is being multiplied by addition. So we can divide out across, everything is being multiplied by each other. So we can divide out across this multiplication because the addition and subtraction are contained within the parentheses. So my x plus 1s, those are going to divide out to 1. And therefore, I'm going to leave me with the final answer of x minus 4 divided by 4 times 3 is 12. And then we have an x minus 1 and an x minus 6. So there you go, ladies and gentlemen. That is your final answer on how to simplify complex fractions. Thanks. So let's cover a general problem here. X over, let's just do x plus 1. Plus, let's do, 1 over x minus 2 divided by 3 over x squared minus x minus 2. All right, let's pretend we had a complex fraction like this. Now, a couple things to remember. We didn't like fractions, right? So what we worked on this was eliminating our fractions. Now, in Algebra 2, many of you guys were very quick to remember, well, if we always get the common denominator, then we can just use the numerators, right? And that's what you guys had embroidered in your memorized. And that's fine. Like, that works. And then you factor this, and you say that's x plus 1 times x minus 2. So that got simplified, right? And so now you can see that they all have the common denominators. So then you took the numerators. Now, I didn't really like that explanation because many of you guys didn't understand why that worked. So what I explained to you is the reason why that works is because once you get common denominators, now you can multiply everything times x minus 2 times x plus 1. And when you do that, the denominators all get divided out, and you're just left with a x times x minus 2 plus, let's change this to a minus, minus an x plus 1 all over 3. Right? And now, can we just go ahead and simplify this to give us an x squared minus 2x minus x minus 1 over 3, which is x squared minus 3x minus 1 divided by 3, right? And then the other thing we want to talk about is the restrictions, right? Remember, guys, the restrictions are the values that x cannot equal. Well, if you look at the simplified problem, is there any values that x cannot be? No, but remember when we were talking about restrictions, adding, subtracting, multiplying, dividing, and complex fractions, we just didn't care about the simplified result. We also had to look over here and say, well, the original problem, I know x cannot equal -1 and 2, right? Because that would have made my denominator 0 in my original problem. Correct? So then we talked about those restrictions. OK, so that's complex fractions. Now, let's pretend you have a rational equation that looks very similar. OK, now before we even go any further, I actually didn't teach it this way, but it's actually a good idea to do this, because I think this helps you guys understand extraneous solutions better. Do we already have some values that we know x cannot equal? Yeah, why don't we just write those down? X equals -1, or x cannot equal -1 and positive 2. You guys agree with me? OK, so let's just actually kind of leave that to the side. We know, based on this original equation, it cannot equal those. Now, rather than doing the Algebra 2 method this time, I'm just going to go the way that I taught you. I said, guys, yeah, that makes sense, and you can do it. But in reality, why get the common denominators and then multiply by the common denominator? The easiest, the faster way that you can do it is just multiply by the common denominator. Now, students usually didn't like this method because they had a hard time identifying the common denominator.
But if you look at identifying the common denominator like you did in Algebra 2, you can still, you can identify what the common denominator is rather quickly. And it's just going to save you a little bit of work and time. Because obviously, this now gets divided into x plus 1, x minus 2. OK. And the reason now doing it this method, it's the same thing you're doing here. But what happens is when you multiply this common denominator times every single term, like when you multiply this times this fraction, the x plus 1's divide out. Agreed? So we're just left with an x times x minus 2. When you multiply an x minus 2 times x plus 1 with this, the x minus 2's divide out, and you're just left with a x plus 1. And then here, the denominators divide out, and you're left with a 3. If you wanted to do common denominators and do the Algebra 2 method, there's not a problem. I just feel like this process is a little bit sooner. Now, if you guys remember on your quiz, actually we reviewed these. Because I was so happy. I'm like, oh my god, you guys got all the, majority of the class went from here to here. And I was like super happy. And then I got super bummed because looking at this, I noticed that many students stopped right here. It's like they had no idea what to do from this point. We're solving, guys. If it's one variable x or it's linear, use inverse operations. But what you guys figure out is crap. This is not linear. This is a quadratic. So for a quadratic equation, we got to set this equal to 0 and either solve by factoring or by the quadratic formula. And I think I gave you guys one of each on your quiz. So when I set this equal to 0, oh, sorry, that's a minus 3x. Minus 4 equals 0. Now, I want to go and check now I got to go ahead and solve this. So I go ahead and solve. And by factoring, fortunately, I chose something that is factorable. And x equals 4, and x equals negative 1. However, let's go back to that original idea that we talked about here. That solves the equation here. But is negative 1 work for our original problem? No. So this is extraneous. And I think it's important for you guys to understand because some test questions I've seen, the answer choices look like this. Right? So it includes both 4 and negative 1. So if you algebraically get this, but you don't understand that it's extraneous, you would be tempted to do answer A. Right? But the real answer is B. OK? Or some people will just notice that negative 1 is a solution, and they see no solution, then they figure maybe, but no, 4 is a solution, just not negative 1. OK? So a lot of you guys, when we are solving rational equations, like to get the common denominators, get everything that have common denominators, and then you just wrote an equation with the numerators. Right? Yep, a lot of you guys remember that. So here we have all these fractions. Why don't we just do the same thing? Get them to all have the same common denominator, and then we'll just take the numerators. So what I'll do over here is I'll multiply by x over x, 3 over 3, x over x, and 3 over 3. Now they all have the same denominator. I can just take the numerators. But a lot of people, when I would ask students why can you just take the numerators, most students didn't know why. And the reason why is because once you get common denominators, if you multiply by that LCD, which I did over here, my first step, what you guys see is all the denominators divide out with the LCD. Right? So mathematically, it works. It makes sense. But so you can get common denominators, just take the numerators. That's fine. But the reason why it works is because really, technically, what you're doing is multiplying by the LCD. Your method is just not really showing that. But either way, you're getting a 3 plus x over x minus 3. So a rather easy, thank you. All right, and now let's look at the restrictions. Based on my simplified answer, what can x not equal? And then based on my original equation, what can x not equal? There we go. If you guys look at this, it looks pretty crazy, right? But what I want you guys to understand here is basically, this is an expression being divided by another expression. All right? Do you guys see that?
This is what we call a complex fraction. Now, there's no equal sign like we did over there. However, the process for simplifying complex fractions is going to be very similar to the process for solving rational expressions. Because you guys see there's a lot of fractions going on here, right? Yeah. You have each individual fraction in the numerator and denominator, and then you have a whole big fraction, right? So what I'd like to do, again, is eliminate the fractions. Let's get rid of all these fractions. So to do that, we're going to want to multiply by the least common denominator. So in this problem, you guys can see that if we go to every single denominator here, right, you guys can see, oops. You look at each denominator in the numerator and the denominator, you guys can see that the LCD is equal to 3x times x plus 2. OK? And now what I'm simply going to do is multiply every single term by 3x times x plus 2. And what that's going to do is that's going to eliminate at least the fractions in the numerator and the denominator. I'm still going to have a division problem. I'm still going to have an overall fraction. But that's at least going to simplify or get rid of all the denominators. So let's see why that works. 3x divided by 3x divides out. Here, the x plus 2's divide out. X plus 2's divide out. And then here, the x's divide out. OK? So by multiplying everything by the LCD, do you guys see how all my denominators have now been divided out? Yes, George.
X, what does it divide out from? Okay.
Do you guys see that, though? That's really, really important for you guys to see that now my denominators have all been divided out. So I multiply everything by the LCD. So the multiplying by the LCD gets rid of your denominators. It's helpful for complex fractions. It's also helpful when solving rational expressions. So now let's write in what we have left. Over here, I just have x plus 2. And then over here, I have minus 3x. So it'd be like a 12x times, oh, that's just it. And then that's all over. Over here, I have, actually, let's write it out. Negative 4 times 3x. And then over here, I just have 3x times x. And then over here, plus 3 times x plus 2. So do you guys see how I wrote in what is just left over? And now we can simplify that, right? You guys are familiar with doing this kind of stuff. Apply distributive property. Yeah. Yeah, it's separated by addition or subtraction, so we can't do it. OK? So therefore, I have x plus 2 minus 12x divided by 3x squared plus 3x plus 6. Here, I can combine these to 2 minus 11x divided by here. I can factor out the 3. And that'll leave me with an x squared plus x plus 2. I factored a 3 out from the bottom denominator. OK? I just factored it out. And then I left it like this. We can't factor what two numbers multiply to give you 2 but add to give you 1. We don't have any. No, but the x plus 2, x minus 1 would give you negative 2. And they add to give you 0. That's not factorable. It's not factorable. You can't. Leave it like that. So then, that is going to be your simplified complex fraction. In this one, we have two fractions. We have fractions in the numerator and fractions in the denominator. Now, this is, again, another example of a complex fraction. And if you guys remember when we first did complex fractions, if you guys remember in your last focus lesson, not the one today, but in the last 2 class periods ago, what we did to get rid of complex fractions was we multiplied by the LCD. And guess what? You could add these if you like, and then subtract these if you like, and then combine them. But my best thing is whenever I have variables in the denominator, I want to get rid of all my variables. So what I'm going to do is I'm going to determine my LCD, and I'm going to multiply everything by my LCD. So the LCD, or least common multiple of my denominators, which we call least common denominator, is going to include Does x plus 5 divide into that? Yeah, it goes in there x minus 6 times. Does x minus 6 divide into that? Yeah, it goes in there x plus 5 times. OK? So both of my denominators, or all of my denominators, divide into that expression. Do you want me to re-explain that another way? Yeah. OK. Basically, guys, again, as I mentioned, x, all I'm saying, if it's a multiple, right? Think about, remember when I did 3 and 6? I said 3, 6, 9, right? 6, 12, 18, right? I said the common multiple was 6. Because does 3 go into 6? Yes. Does 6 go into 6? Yes. So you take your common denominator, and you say, hey, does x plus 5 divide into that? Sure it does. X minus 6 times, right? And then you say, does x minus 6 divide into that? Sure it does, right? Because that divides the 1. It goes in there x plus 5 times. So do you now agree with me that all of these divide into that common denominator? That's why just multiplying the denominator is so helpful when you have polynomials. Because it's always going to produce you something they divide into. So now I'm going to multiply everything by my LCD. No. Oh, you need me to help you out? Oh, sorry. Trash can's over there. I know it's sometimes hard to get over there. So you have to multiply your numerator and your denominator by your LCD. Remember equivalent? Remember, see how I multiplied the numerator and denominator? I'm going to do the same thing over here. But my goal in this case is not to produce equivalent denominators. My goal this time is to eliminate the denominator. Now, notice how this is an expression. This would be like x plus 4 or something. You have to multiply times both of them, right? You can't see how these are separated? 5 times x plus 4. You have to apply distributive property, right? These fractions are separated by addition and subtraction. You have to apply distributive property. Yes? Right? So in reality, I'm just going to write it over here to make it more sense. So I'm going to say the product of this times that, and this times that. Now, let's have fun using the zero product property. Once you understand, you take for complex fractions, when you have an expression divided by another expression with fractions, multiply everything by the LCD. Let's see what happens. Well, here, x plus 5 divides into it, right? Here, x plus 6 divides into it. Here, x minus 6 divides into it. Here, x plus 5 divides into it. So now I'm left with 4 times x minus 6 plus 9 times x plus 5 all over 5 times x plus 5 minus 8 times x minus 6. Do you see how I have no more fractions anymore? I mean, I just have one general fraction. That's it. And then you guys can just go ahead and simplify your work. Apply distributive property, apply distributive property. Final answer is 13x. Let's see, that's going to be, whoa, cross what up? Over here? We can't cross the x plus 5s out because look at what these terms are separated. They're separated by addition and subtraction. Remember, the division property only works. See how everything is separated by multiplication and division here? That's why I can apply the division property. But once you separate terms and expressions by addition, you can't apply the division property.
13x plus 21.
Plus 21.
Negative 3x.
Okay. And you can't factor anything else out from there, simplified. Okay? So whenever you guys are adding and subtracting, or especially when you guys have complex fractions, the best thing I want you guys to do is, one, identify the LCM, and let's get rid of this crazy stuff that we have going on in the numerator and denominator. So To get rid of these, all I simply need to do is multiply every single term by my LCM. So let's figure out what the LCM is. Well, here I can factor this. Difference of two squares tells me this is a factored form of x minus 3, x plus 3. So if you guys look at this, the common factor, or the common multiple for all of these has to contain at least an x minus 3 and an x plus 3. Does everybody agree with me? So my common multiple is x minus 3 times x plus 3. Now, all I'm simply going to do is basically you're multiplying your LCM and your numerator and your denominator. But when you do that, since they're separated by addition or subtraction, you have to apply distributive property, correct? So in reality, you guys are going to multiply everything by your LCM. And since you're multiplying, that means everything is separated by multiplication. So since they're separated by multiplication, you can apply the division property. OK? So now we just had the war of division property. Let's clean up and see what we have left over. I have 2 times x plus 3 plus 3x. That's left in the numerator, right? Because I factored those out. Right? That's all I got left. Denominator, I have 3 times x minus 3 minus 4x. So we don't need to be lazy. We can do this. 2x plus 6 plus 3x. 3x minus 9 minus 4x equals 5x plus 6 over negative x minus 9. And there you go.